TingMath Differentiation Part 3. Today, we are going to learn about some applications relating to differentiation. We went through all the troubles of learning differentiation, and now we are going to learn why we need differentiation and how it applies to us in our real life. All right, so let's begin. The first thing is don't panic, yeah? All right, yeah, just kidding, but really don't panic. Math is okay and you can do it. All right, let's go. So the first one is to try to find the least material to use when we are building something. Okay, so let's go to our case study. Let's imagine ourselves to be a drinks company. Let's say we are Heineken, right? And we want to make closed right circular cylinders with a volume of 300 cm3 each, like this one. It's kind of like our cans, right? Our cans of drinks. Yeah. So we want to make those cylinders. Well, the boss wants to cut costs and use the least material possible. So now we gotta examine what is the radius of the cylinder for the total surface area of the can to be minimum. So yeah, your boss wants to save money, simply put. So what we have to do to help him save money, let's look at the question. We need to find the question is asking about the radius as well as the total surface area. So we got to prepare this kind of equation. So let's first express in terms of R a few things. So let's begin. Okay, so let's express in terms of R first, the height HCM. So to express this, we gotta use some things that we know. So this is 300. The volume of the cylinder is 300. Another way to write it, as we know, volume of cylinder equals to pi r squared multiplied by height. So our height here will be equals to 300 divided by pi r squared. Just divide both sides by pi r squared. Okay, now we got our first expression, height. Now we gotta find our total surface area, ACM squared. So let's form an equation again. So surface area of a cylinder, let's find these two circles first. Area of these two circles on the top and the bottom. So that is, area of a circle is pi r squared, and I have 2, so just simply multiply it by 2. And then let's find the surface area here. Surface area here would be 2 pi r multiplied by h. But we are not done yet because we need to express in terms of r. So we are going to plug this in. And what we have now is 300 over pi r squared. Now we need to simplify it, so cancel the top, cancel the bottom, and we are left with area equals to 2 pi r squared plus 2 times 300 is 600 over r. Alright, simple and easy. Great. Now we have the equation. Now that we have the equation, we are ready to find the radius that we need to design our can for it to be the cheapest. All right. So using this, we're going to find the minimum surface area for a particular value of radius. So if we remember, for the minimum surface area, the gradient dA over dr will be equals to 0. So first, let us differentiate A with respect to R. So differentiate this, what we get is 4 pi R. And if we differentiate this, we will write this in indices form. So this in indices form is 600 R to the power of negative 1. Bring down the negative 1, we have negative 600 R to the power of negative 2. So dA over dr will give me this. Okay. Now we simply have to make dA over dr 0 because, as we mentioned, that's when their gradient is 0. So this one here, once we are done with this, we can just solve for r. So 600 over r squared will give me 4 pi r. Multiply on both sides, what happens? 600 equals to 4 pi r cubed. So r cubed will be 600 over 4 pi, and my radius will therefore be the cube root of 600 over 4 pi. And 600 over 4, well, it's 150, so 150 over pi. And then just press your calculator and voila, we will get the answer for the radius. So now we know how to design our can. So differentiation is not that useless after all, huh? Okay, let's try another example. Let's imagine that we are a landscaper now. So we're a landscaper and we are building a fence to completely enclose a part of our backyard for a garden. Well, I have material for a fence that is 100 meters long. So I have enough material for 100 meters long. I want to find out the largest rectangular area that the fence can enclose. I mean, who doesn't want the biggest garden, right? The biggest area of a garden. So let's understand the question. We want to build a rectangular garden. We have enough material for 100 meters long. Let's make the breadth x. Let's let the length be y. And let's try to form some equations so that we can work on the problem here. So here we know that x plus y gives me 100 meters. That's the parameter. So 2x plus 2y equals to 100 meters. And let us find y in terms of x. So 2y will give me 100 minus 2x. And y would be 50 minus x. Simply divide the both sides by 2. Okay, now we are ready to start with the area. So area here is equals to, area of your garden will be equals to x multiplied by y. And because we don't like so many variables, so we're going to write everything in terms of x. So my area, I'll let my area be a. A equals to 50x minus x squared. Alright, so this is a quadratic equation that looks probably something like this. And remember, at the maximum point, my gradient, it will be 0. So now I know that. I know dA over dx will be equals to 0 at the maximum area. Right? Let's differentiate a with respect to x now. This one would give me 50 minus 2x. As I know it's 0, we're going to put 0 in to the equation, and we're going to solve for x. And what we get here is that we find our x to be equals to 25. So x here, now we know one side is 25 meters. Okay, so we find out how we are supposed to build our garden. For the largest rectangular area, you simply need to take 25 multiplied by 25. We know here is 25 as well because y is 50 minus 25 here. Yep. So that is our answer for the largest rectangular area. So hopefully you guys are more motivated to learn about differentiation because it kind of actually makes sense. It helps you save money sometimes. Yeah. So thanks very much for watching. And if you have any feedback, do leave them down below. And all the best for your math and differentiation and learning journey in life. See you!